Hello everyone, this is Hating Tian. This video we're learning geometrically defined vectors and applications. Let's see what is a vector. Quantities such as force and velocity involve both magnitude and direction. The magnitude is such as the real numbers. For example, the height is a real number. For example, my friend, he is 6 feet tall. So the 6 is the magnitude, or 6 feet, we say this is magnitude. And the vector also need to have the direction. For example, the velocity is a vector. I'm driving my car to the east. So the speed, the velocity, I say, is 60 miles per hour. So 60 miles per hour is the magnitude, and going to the east is the direction. So we combine them together. This is the vector. So the velocity is the vector, and the force is also a vector. How to describe a force? We can use direct line segment. For example, I have PQ. So this represents the vector from the P point to Q point. So from P to Q, okay, this is a direction. The length from P to Q, we call this magnitude. For example, my speed is 60 miles per hour. So the length from here to here, is 60 miles per hour. So if my friend she's driving very slow, so she's driving the same direction, but she's driving very slow. So the magnitude represent the length of the vector. So the magnitude or the length of her vector is 50 miles per hour. So she has a short line segment. And the initial point is P, terminal point is Q. And from P to Q, that tells you the direction of the vector. And the vector, you can move the vector in the 3-dimensional, 2-dimensional. So, but you must move it parallelly. You cannot say you make a U-turn or you change the direction. So let's see the figure 6.16. So you see all of these vectors, they have the same length, or we say they have the same magnitude, and they are all pointing to this direction. So they represent the same vectors, or we say these vectors are equivalent because they have the same length. That means they have the same magnitude, and they are pointing to the same direction. And for example, I'm driving my car to the north, and my velocity is 60 miles per hour to the north. So I'm driving my car to from Houston. So initial point is Houston to the north. And my friend is driving her car at New York at this point. And also she's driving to the north, and she has the same velocity, 60 miles per hour, and driving to the north. And me and my friend, we have the same velocity, same vector, because we are driving to the north 60 miles per hour. So magnitude and direction are the same. So we have the same or equivalent velocity vector. All right. Most of the time we're using the lowercase v, u, and w represent the vector. How to find the sum of the two vectors? Make it bigger. So we have two methods to describe the sum of two vectors. For example, I have two vectors. Their name is AB. So you will see the A and B. So I can move the AB anywhere parallelly. So place the initial point of the vector B at the terminal point of the vector A. So look at this. If I have two vectors, AB, maybe A is here and B is here. So I will move this one, move the B here. So we'll make the head of the A point to the tail of the B. You see, head to tail. So let's move them together. And then connect the initial point of the A and then point to the terminal end of the B. Then the red, I think it's pink or red. So the pink segment. So this one is the sum of A and B, vector A and B. We also call this resultant. And so for example, now I have a segment A. I have a segment B, for example. It's like this, B. So I can move the B parallelly to here. This is the B. And you see, oh, this is the head, this is the tail. Then I move them to the correct position. Then line up the initial of the A and the terminal end of the B. So this is A plus B. We also create the triangle. Another method to form a consultant of A and B, or the sum of AB, is a parallelogram rule. First we place the vector A and B so that their initial points coincide. So O lets them to have the same initial point. Then complete the parallelogram. Okay, that means we can make a parallelogram. So this one is parallel to the vector A, and this one is parallel to the vector B. Then we construct a parallelogram. And then the sum of the AB is diagonal. So from the point here to here, this is the sum of the vector A and B. And we need to know something about the parallelogram. So for the parallelogram, so the B and its opposite side, they're parallel to each other. Also, they have same lengths. For example, the B is 5 meter, and the opposite is side is also 5 meter. So A equals 10 meter, and then its opposite the segment is also 10 meter. Oh, that means, look at this. Oh, that means the first method and the second method, they are very similar. You can move one of them. For example, if I want to move the B, why? Move this B to here, because I know I can move any vector parallelly. So move the B here. Okay, you see, head to the tail, and then the diagonal, that is the sum of AB. And also you will see I constructed I made a triangle. That's not right. So this one is a triangle. I can solve my triangle. All right, let's see. Oh, something about the diagonals. For example, if I know this angle, I said this is, how about 80 degree? And then, can you find this angle? Okay, we have learned that if we have two parallel line and a line goes through it, so if I have a line goes through it, then these two angles, the sum equals the sum equals 180 degrees. They are supplementaries. All right, let's see here. This is 80 degree, and these two lines, they are parallel to each other. And then this angle plus this angle is 180 degree. That means 180 minus 80 is 100 degree. Okay, this is 100 degrees. All right, that means if I know the angle between A and B, so I can move the B to this side. And then I know this is A, this is B, so I know the angle between the AB, so I can find the opposite of the angle 100, the length of the opposite of 100. All right, let's see next part. I want to erase this, it's too messy. Let's see, the scalar product of a real number k and a vector u is a vector k times u. So if I have a scalar k, so scalar means it doesn't have a direction, like k equals 1, 2, 3, 4, negative 1, 2, 3, 4, or 1/2, 1/3, and multiply by the u. That means if the k is positive, we change the magnitude of the u. For example, if I have a vector u, 2u means I stretch it 2 times. So 2u, you see, it's longer, but the direction keep the same. If I have 3/2 times u, so I stretch the u to the 3/2. And then once 1/2 of the u is, you see, is the half length of the u. And how about negative 2u? We have a negative sign. So if you see a negative, that means to change the direction. You see the direction is opposite, and I also stretch it 2 times. All right, let's see the example 1. Make it bigger. Example 1, find the magnitude of a plus b. So it gives us that the a is 4 pounds and the b is 8 pounds, and they move the AB together, and they have the same initial point. And how to find the sum of AB? If the picture move them together, we know that how to make a parallelogram. We make a parallel line, and then make another parallel line here. So the sum of AB is the diagonal between, diagonal of this parallelogram. How to find the magnitude of a plus b means how to find the length of this diagonal. So let's find the length of diagonal. First, I'd like to move all the a, b, and a plus b in one triangle, because we know how to solve all kind of shape of the triangle. So how about move the A? You can also move the B, it doesn't matter. How about move the A to its opposite? So let's use this color. So how about move the A here? The A is here, because they have the same direction, same magnitude. Yes, now I have the triangle. Okay, I see a triangle here. So the length of A and B is given. So B equals 8. B equals 8. A equals 4. And how about the angle between them? So this angle is 60. And then, so this is 60. Then this one, this angle Q. So Q equals 180 minus 60. That's 120 degrees, because Q and P, they are supplementaries to each other. So the sum is 180. All right, so we have the B, we have the A, we have the angle between A and B. What should I do? We can use the law of cosine, because that's opposite of the Q. So law of cosine is to find the magnitude of AB. So magnitude of A plus B, it doesn't ask any direction. So this one is the longest side. And also that's the opposite of the Q. That equals A squared plus B squared minus 2AB times cosine Q. Q is 120 degree. And then the magnitude of A plus B. So to describe the magnitude, we can put it like the absolute value of that vector. For example, so magnitude of V, you see two straight lines. And some book, they use double straight lines. This also represents the magnitude of the vector V. All right, so the magnitude of A plus B is square root of A squared plus B squared minus 2AB times cosine 120 degree. So we can use our calculator to do the computations. 4 squared plus 8 squared minus 2 times 4 times 8 times cosine 120 degrees. Excuse me. Let's use the calculator to find the solution. So square root of A squared is 4 squared plus 8 squared and minus 2 times 4 times 8 times cosine 120. Make sure your calculator in the degree mode. So it's 10.5830. So if the question says round to 1 decimal places, so I'm having 10.6 pound because the unit here you see is pound, so we cannot change the unit. So this is the magnitude of A plus B. Also we called this is a consultant magnitude of the consultant A plus B. All right, let's see next one. I have two force. One force is 15 and another force is 22 Newton. Act on a point P in the plane. If the angle between the force is 100 degree, find the magnitude of the consultant force. Magnitude of consultant force. So we know PS. So PS, PQ, we construct a parallelogram, and the diagonal, the PR, the pink segment is the consultant. That's the sum of the two force. Maybe I can say the consultant force name is V. How to find the V? Like the previous one. First, I can move the two force, 15 and 22, and the V in one triangle, then I can solve it. How about move the PQ, the 15 one, to its opposite? So I use blue color. So I move it here. Okay, in this triangle, so now I'm having this triangle. What do we have? I'm looking for the V. And I have 22, I have 15. I don't know this angle because even the graph has the 80, but I don't know it from the question. From question, the force is 100. So this angle is 100. So this is 180 minus 100. That means 80 degrees. All right, let's move on and only look at the triangle. So only look at this triangle. Okay, in this triangle, we have, what is the case of this? We have learned SAS case. Is this SAS? SAS. Yes, this is SAS case. So I can use law of cosine. Law of cosine to find the magnitude of V. V squared equals 15 squared plus 22 squared minus 2 times 15 times 22 times cosine 80 degree. And the magnitude of V equals square root of 15 squared minus plus 22 squared plus, minus 2 times 15 times 22 times cosine 80 degree. So let's use our calculator to do the computation. We are looking for square root of 15 squared plus 22 squared minus 2 times 15 times 22 times cosine 80 degree. And hit enter. So if I round to 1 decimal places, I'm having 24.4. So I'm having 24.4. The unit, unit is pound. All right, we're done. Let's see, next one. Find the force required to keep 50-pound wagon from sliding down a ramp inclined at 20 degree to the horizontal. What's the meaning of this? If I have a wagon stay here, so it has a force going down because it's 50 pound. So the 50 pound, this force can divide it into two parts. One is horizontal, not horizontal, is parallel to the incline, the ramp, and another one is vertically to the ramp. So this one and this one. So we divide it into two parts, and you see this part force let the wagon going down, and I need another force, we say F. So we need to have this going up or parallel to the ramp to stop my wagon going down. So we are looking for the magnitude of the force F. So what is the force that stop my wagon going down? So this force, and this force, they are the same. They have the same magnitude, but they have opposite direction. And we can find the magnitude from the triangle. So I can move this one here. Or I can move the force. So I can move the force here. Here. Okay. So make it clearer. So I can move the force to the bottom. Then I construct a right triangle. So I construct a right triangle here. So if I know some information, I can find the AC. I want to find the F equals what? So how to find that? I rotate my my triangle, my right triangle. You see, is the shape like this, going down, and then like this. So this one is 50, and this one is unknown, and this is a right triangle. Okay, right angle. So how to find the question mark here? What is the length? Okay, we have very few information in this right triangle. We do not know the angle here. Even the picture shows you is 20. But why it is 20? Let's see the angle here. So this angle plus this angle equals 90 because, this is 90. We can say this is angle alpha. So 20 degree plus alpha, that's 90. And also, look at this. Do you think this is 90 degree? Yes, it is. So this angle we call the alpha. So alpha plus this angle, question mark, I say, it also equals 90. We have learned 20 degree plus alpha is 90. And alpha plus what is 90? Oh, question mark is also 20 degree. That means we have the right triangle and this angle is 20 degree. So we got this 20 degree. And then in this right triangle, we have the hypotenuse and we have one angle. Can you find the opposite? Okay, let's see. For the right triangle, if I'm using the sine function, sine 20 degree, so this is 20, equals opposite, which is, we say, the magnitude of f divided by the hypotenuse, which is 50. Okay, from this, I can find the magnitude of the f, multiplied by 50 both sides. 50 times sine 20. Let's use our calculator to find this. 50 times sine 20. So it's 17.1 if I only keep one decimal places. So it's about 17.1. And the unit is pound because here the unit is pound. All right, this is an interesting question. Okay, how about next one? Let's see the next one. So number 4, a force of 13 pounds is required to hold a 66-pound lawnmower on a hill. Oh, it's very similar like the previous example. What's the meaning of that? So I have a lawnmower stay here. So if I want to make my lawnmower stay here, that means I have a force going down because it's 66-pound lawnmower. So this force needs to be balanced with this one. And the question is asking about the angle theta. Okay, it's asking about the angle theta of the hill. All right. Let's see, we have proved that theta and the angle here, they have the same measure. So that means I said this angle is also theta. So if you don't know, go back to see the example 3. Why the theta and the angle here, they are equal. And then we are looking at the right triangle. This is the 66-pound of the lawnmower, and this is the 13-pound force to stop my my lawnmower going down. Then I'm looking for the theta. Okay, that means, let me erase this. That means I can use sine because the 13 is opposite of the theta. And 66 is the hypotenuse. So I'm using 13 over 66. And the theta equals the inverse of 13 over 66. Let's use the calculator to evaluate that. Second sine, 13 divided by 66. Close the parentheses and hit enter. So that's 11.3598. If I keep one decimal place, it's 11.4 degree. 11.4 degree. All right, this is an interesting question. Let's see next one. A ship leaves port on a bearing 29 degree and travels 9.6 miles. The ship then turns due east and travels 4.4 miles. How far is the ship from the port? What is the bearing from the port? Okay, let's see. The initial point is P. From the P, so first he is traveling the bearing of 29. So this one is a single measure bearing. That means we are starting from the north and then rotate to the clockwise direction 29 degree. So first my boat is starting from P and then going to this direction, got here. So this length or the magnitude is 9.6. All right, at the point A, change the direction. It's going to the east. It travels 6 4.4 miles. Then my ship stop at the E point. How far is ship from the P to E? All right, look at the information here. If I'm looking for the distance from P to E, I have the side here. I have one side of the triangle here. And if I can know the angle here, so use law of cosine, I can find the distance from P to E. Okay, how to find this angle? I call this angle theta. Okay, let's see. In this image, 29 plus this angle, I say this is alpha. 29 plus alpha, 29 degree plus alpha equals 90. Because this is a right triangle, the sum of 29 and alpha is 90. And can you solve for the alpha? So 90 minus 29 is 161 degree. And also I know the alpha and the theta, they are supplementaries. That means alpha plus theta equals 180 degree. So theta equals 180 minus 61. This is this 1, so 119 degree. Okay, we know the theta. I'm looking for the magnitude of the opposite side. So we say, maybe we can just say the vector here is v, make it easy. So the magnitude of v squared equals 4.4 squared plus 9.6 squared minus 2 times 4.4 times 9.6 times cosine 119 degree. And the magnitude of v equals square root of everything. So I copy again, 4.4 squared plus 9.6 squared minus 2.4.4 multiplied by 9.6 times cosine 119 degree. So we must use our calculator to do the computation. So we have square root of 4.4 squared plus 9.6 squared minus 2 times 4.4 times 9.6 times cosine what? 119. Close the parentheses. Let's see, it's about 12.34. Round to one decimal place. I have 12.3. I have 12.3. And the magnitude unit is mile. Okay, I found the length of the V in the triangle. And what is the next question? What is the bearing from port? All right, let's see. The bearing from the port now for the point E is from north line, and then do the rotation like this. So I'm looking for the angle here. And how to find that? I know this partial of the angle is 29. How about this? If you can find this, I say this angle is beta. You can find beta. The sum of the 29 and beta is the bearing of the point E. How to find the beta? Let's say this angle is beta. So in this triangle, bad drawing. We have two sides, and we have three sides. Can you find the and also we have the angle here, because in previous steps we found the angle theta is 119. So we have too much information here in this right triangle. So can you find the angle beta? Yes, we can. How about use the law of sine, because we used the law of cosine to find the opposite of the 119. I can use beta. Opposite of beta is 4.4. 4.4 over sine beta equals, so opposite of 119 is 12.3 divided by sine 119 degree. Then we need to solve for the b. Both sides we flip. Sine b over 4.4 equals sine 119 degree divided by 12.3. And then we are looking for the sine b multiplied by 4.4 both sides. 4.4 sine 119 degree, all divided by 12.3. And the angle B is the inverse of sine 4.4 sine 119 degree, all divided by 12.3. Close the parentheses. So let's use our calculator to do the computation. The inverse of sine 4.4 times cosine, times sine, I think. Yes, sine 119. Sine 119, all divided by 12.3, close the parentheses. All right, the angle is about 18.2 degree. So the B is about 18.2 degree. And then the sum of 29 degree plus the beta 18.2 degree, then so it is 47.2 degree. So the bearing is, the second question is bearing is 47.2 degree. And the first question is from the P point to E point is 12.3 mile. All right, we're done for today. If you have any question, please let me know. See you next video. Bye-bye.